when we're talking about sampling, it's important to sort of start with some of the basic sampling concepts and ideas that kind of go into the reason you would pick different type of sampling methods. So starting off with just the some of the key terms that we need to know when we're talking about sampling. So we can start, and I kind of have this inverted triangle kind of to represent kind of how much we're trying to include with each of these terms. So the universe is kind of like the complete collection of all possible, whether it's people, groups, organizations, whatever it is you're looking at, related to the concept of interest. And basically it's all conceivable. And so the universe, really, we don't really use that term all that often, but really it's sort of that one step about that is like all possible things that could potentially be related to this, this thing that we're studying. But then we move it down a little bit, and this is where we get to our population, or sort of our target population, which may not be the same as the population, but the population is basically the group that we want to generalize to. And so the universe is like this all conceivable, whereas the population is all real cases that we want to really talk about. And so we'll say our target population, because there might be a larger population that might be kind of relevant, but we are more specifically focused on some target population. So maybe it'll be, the population might be, all Americans, but really our target population might be, all Americans that would be at the age to be going to college. So that would sort of narrow it down a little bit. And so whether you're talking target population or population, it's basically the group that you want to talk about, that you want to generalize your information you're getting in your study, you want to generalize to that population. So then we move down a little bit more, in the sampling frame is basically the list of the population that you're going to sample from. And so, back in the day, this would be like a phone book. I guess people still kind of can use that for sampling, but it just wouldn't be as effective or as accurate. But, if you wanted to say your target population was all players in the NHL, and so then your sampling frame might be a list of, each of the team rosters that you're going to sort of combine together. Or if we're looking at students, then maybe it's a student registrar list. So something like that. So the sampling frame is really any kind of list that you're going to try to get your sample from. And it may include the entire population. That would be the hope. But sometimes we lose out a little bit on sort of having access to that entire population. But a good sampling frame would include the entire population, or at least the entire target population, but not necessarily. And then we move down to our sample, and our sample is our group of people or groups or organizations or whatever we're sampling. Typically it's people, but the sample is the group of people that you're actually getting information from. So that would be the group that is giving you the data or the information to then generalize and use that information to run statistical analyses or whatever you're going to do with it to then generalize to the larger population. And then we go down even further, and an element is just one individual member of that sample. So if your sample has, it's a sample of an N of 50, which means there's 50 individuals, then that means there are 50 elements in your sample. That's all that means. So generalizability is an important component and sort of thing to talk about when we're talking about sampling, because we want to be able to generalize our information that we get from our sample to that target population. So there are two types of generalizability. Sample generalizability is we want to generalize from a subset, our sample, to a larger population that sample came from. So this is kind of the pictorial representation of this. So this orange circle is the entire population that we want to talk about. We get our sample from that population, and then we want to be able to talk about the population we drew that sample from. Compare that to what's called cross-population generalizability, or sometimes we can call it external validity. And this is when you want to generalize the findings about one group, population, or setting to other groups, populations, or settings, which means that we're taking our sample from a different population and then trying to apply it to a population that our sample couldn't have possibly come from. So a good example of this, say at MSU Northern, I get a sample of students that I'm going to talk to, and then I want to generalize to all MSU Northern students. So this would be sample generalizability, where the orange would be all MSU Northern students. I get a sample of MSU Northern students, and then I get information from them. I run my analyses, and then I want to talk about all MSU Northern students. That would be sample generalizability. If I want to then take that information I got from MSU Northern students and talk about, say, MSU Bozeman students, or really any other college sample, that would be cross-population generalizability. So the people that I want to talk about at, say, MSU Bozeman, they couldn't have possibly been in my sample because I got my sample from all MSU Northern students. But I want to then talk about MSU Bozeman because I think it's a similar population, and I think that whatever I get from my Northern students would make sense to apply to Bozeman students. So that's just sort of an example, but the difference is that sample generalizability, your sample came from that population you want to talk about. Cross-population generalizability, it didn't. It came from a different population, and then you want to talk about a population that couldn't have possibly had a chance to be in your sample. So representativeness is a really important feature that we want to make sure we address when we get a sample, because if our sample is not representative, it's not a very good sample. So a representative sample essentially is a small group. It's much smaller than the population, we know that, but it looks like the population that it was selected from. And so it's representative of the larger group. And this, when we say it looks like, it means like the distribution of relevant characteristics are the same in the sample, and then when we compare it to the larger population. So things like, we probably want gender distributions to be relatively about the same. We want racial distributions to be about the same. Maybe socioeconomic status is important, so we want that to be about the same. Age distributions, we want to be about the same. So things like that, where we want to make sure that the sample we're getting is not like super different from the population that we want to talk about. It's not going to necessarily be exactly the same, and actually we don't always know exactly what the population looks like, because by definition it's larger than you can sample, but based on what we know, we want to best guess to make it so that it's representative. And if, say, we're talking about criminal justice related, so maybe we're looking at an offender sample. If we have, say, all our entire sample is like violent offenders, but when we look at the larger prison, there's violent offenders, property offenders, white collar offenders, and so our sample is not going to be very representative if it's all violent offenders. And we know that that's not the case when we look at the entire population of offenders. So an unrepresentative sample then means that some characteristic is either over or underrepresented, or typically you'll have a combination. One characteristic will be overrepresented, and sort of that's the different values of that same characteristic is going to be underrepresented. So, so in that example, we would have an overrepresentation of violent offenders and an underrepresentation of property and white collar offenders, and we don't want that. So here's kind of an example of what this looks like. So if this is, we're just using marbles, and so we have black and white marbles. So if this is what our population looks like, and it looks like it's mostly white marbles with some black marbles scattered in there. If we took this sample is all white marbles. It is not representative of the larger population. If we take a little bit of larger sample, which is one way to increase representativeness, is to have as large a sample as you can get. And so we get a larger sample, and we can see it's mostly white, but we have a smattering of black marbles in there. That is much more representative of that larger population. So this is sample B is a much better, more representative sample than sample A. So then there's something that's called sampling error, which is essentially when you don't have a representative sample. So it's differences between the sample and the population that you drew that sample from. And so you don't want sampling error, because large sampling error means that you don't have a representative sample, which means that it's not going to tell us what we want it to about the population. There could be some major error that's going to come in. It's just because that our sample doesn't look like the population, and that's going to cause a whole bunch of error. And even if we're doing everything else right, that's going to make it so that we can't really use that. We can talk about our sample, but we can't then generalize to the larger population. So there are two main types of sampling methods. So there's probabilistic sampling and non-probabilistic sampling. So probabilistic sampling is literally, it's called probabilistic because you know in advance the chance or the probability that any element of the population, remember an element is like one individual, is going to be selected for that sample. So there is a numerical probability we can give in terms of what the likelihood is that any element from the population is going to be selected for our sample. And so the goal of probabilistic sampling is representativeness. And that the whole point is to make it so that we have a good sample that represents our larger population. And the larger our sample, the more confidence we can have that it's representative. And also the more homogeneous the population, then the more confidence we can have. And when you think about this, let's take it to the extreme. If, say, our population was all college students, then the fact that they're all college students mean that they're all basically the same. And so when we are selecting from that larger population, then we have a really good chance that they're going to be all college students because the entire population is college students. So the more alike the population is, the more confidence we can have that our sample is going to be representative. But that doesn't mean that we don't want a more diverse population. It just means if it is more diverse, it's going to be harder to get a representative sample. You're going to need to get a larger sample for it to be more confident that's going to be representative. And so when you think about the probability of selection, let's just kind of go back to that for a second. It's when we look at the likelihood that any element can be selected from the population for inclusion in the sample, the kind of the easiest way to think about this and to kind of wrap your head around that is if you think of something like a census by definition, the entire population is sampled. Then that means in a census, the probability is 1. Because everybody's going to be selected. So a probability is 1, which equates to 100%. So you have a 100% likelihood of every element being selected because all the sample is the same as the population. Now, non-probabilistic sampling is where you don't know the likelihood in advance. And so non-probabilistic techniques are you don't have that numerical probability or that numerical chance, and it's more about if you can't use probability methods or probabilistic sampling methods, which often you can't. If you have a really small population, it's a really specific targeted population that you want to talk about, or if it's an exploratory study and you don't really have enough information to really go in depth in any of those. So those non-probabilistic, you can sort of think of it more like qualitative kind of, and probabilistic is more quantitative, although that doesn't mean you can't use probabilistic sampling in qualitative or non-probabilistic in quantitative. That's kind of just a way you can think about it, as typically probabilistic sampling methods you would use with more quantitative methods, and typically non-probabilistic would be more likely to be associated with qualitative methods. So it's just kind of another way to think about it.